Welcome to our deep dive into the world of pill bugs, also known as roly-poly bugs. These small, unassuming creatures, often encountered in our gardens and beneath damp logs, lead lives filled with fascinating adaptations and play a crucial role in the ecosystems they inhabit. They are, in their own way, miniature marvels of the natural world, ancient mariners of the terrestrial realm, having made the remarkable transition from aquatic ancestors to a life wholly on land, a feat not easily accomplished. Their segmented bodies, like tiny suits of armor, hint at a lineage stretching back millions of years, a silent testament to their resilience and evolutionary success. Today, we'll uncover some fascinating facts about their life cycle, habitat, and whether they pose any danger. We shall explore the intricate details of their existence, from the moment they emerge as tiny, vulnerable young to their methods of feeding, their ingenious defense mechanisms, and their surprising parental care. These are not mere pests, as some might unthinkingly label them, but complex organisms with a story to tell, a story of survival, adaptation, and ecological importance that often goes unnoticed beneath our very feet. Prepare to see these familiar backyard dwellers in an entirely new light. Join me, Daniel, as we venture into the microcosm beneath the leaf litter to appreciate the subtle beauty and complex lives of these terrestrial crustaceans. We will observe their daily routines, their interactions with their environment, and the unique characteristics that make them so perfectly suited to their niche. This exploration promises to reveal that even the smallest of creatures can hold the greatest of wonders, and that the roly-poly bug, in its humble way, is a true champion of the undergrowth. A tiny titan shaping the world in ways we seldom pause to consider. Our journey into the life of a pill bug begins, as all life does, with a remarkable act of creation. The female pill bug, a devoted parent in her own miniature way, carries her precious cargo not in a nest exposed to the harsh elements, but within a specialized pouch, a marsupium nestled safely beneath her segmented body. Here in this protective haven, the tiny eggs, often numbering from a dozen to several score, are shielded from predators and kept moist, awaiting the miracle of emergence. It is a testament to nature's ingenuity, providing a secure start for these future architects of the undergrowth, a tiny nursery that travels with its guardian, ensuring the next generation's survival. Once development within the egg is complete, a new stage begins. Tiny, almost translucent creatures known as manxae hatch from their eggs, but remain within the mother's marsupium for a short period. These are not yet perfect miniatures of the adults. They are born with one fewer pair of legs, a distinguishing feature of their youth. This period of protected development is crucial, allowing them to gain strength and a degree of resilience before facing the wider world. The mother's pouch provides not only safety but also the vital moisture these young crustaceans need, a legacy of their aquatic ancestry that still dictates much of their biology and behavior, even on dry land. After a few days to a couple of weeks, depending on environmental conditions such as temperature and humidity, these young manxae will venture forth from the maternal pouch. They're now independent, though still incredibly small and vulnerable. Their first task is to find sustenance and shelter, navigating a world that to them must seem vast and filled with giants. Their initial coloration is often paler than that of the adults, their exoskeleton still relatively soft, making them prime targets for any number of small predators that share their subterranean world, from spiders to centipedes. The life of a young pill bug is one of continuous growth, and this growth is punctuated by a series of molts. Because their exoskeleton, their protective outer shell, is rigid and cannot expand, they must shed it periodically to increase in size. This process, known as ecdysis, is a perilous time. The pill bug will seek a sheltered, humid spot for during the molt, and for a short while after, its new exoskeleton is soft, leaving it particularly defenseless and susceptible to desiccation. It's a period of quiet vulnerability, a necessary risk for the reward of growth and maturation. Interestingly, the molting process in pill bugs occurs in two distinct stages. First, the posterior half of the exoskeleton is shed, and then, a day or two later, the anterior half follows suit. This biphasic molt is thought to reduce the period of extreme vulnerability and allow the pill bug to retain some mobility and protection on one half of its body, while the other half is undergoing this transformation. You might occasionally find these shed skins, like ghostly remnants of their former selves, in the damp places they frequent, a silent record of their progress through life's challenging stages. With each successive molt, the pill bug grows larger and its exoskeleton hardens further, offering greater protection. It also develops its final pair of legs after the first molt post-emergence from the marsupium, becoming a true miniature of the adult form. The number of molts can vary, but typically, a young pill bug will molt 4 or 5 times during its juvenile stages before reaching sexual maturity. This period of development can take several months, sometimes up to a year, heavily influenced by the availability of food, the ambient temperature, and the crucial presence of moisture in its environment. Finally, having navigated the perils of youth and the demanding process of molting multiple times, the pill bug reaches adulthood. It is now fully equipped for its role in the ecosystem, its hardened, segmented armor complete, its senses honed to find food and avoid danger. The adult pill bug may live for another 2 to 3 years, sometimes even longer in ideal conditions, continuing to contribute to the cycle of decomposition and nutrient recycling. And for the females, dedicating themselves to the propagation of their own kind, ensuring the continuation of these remarkable little creatures in the quiet, hidden corners of our world. To truly understand the pill bug, we must venture into its preferred domain, the hidden, damp corners of our world, where light seldom penetrates with full force. These creatures are not lovers of the sun-baked earth or arid landscapes. Rather, they are connoisseurs of moisture, seeking out environments where the air is heavy with humidity and the soil retains a comforting dampness. This preference is a direct link to their ancient aquatic origins, as their gill-like structures, called pseudotrachea, require a moist surface to efficiently extract oxygen from the air, a constant reminder of their evolutionary journey. Look beneath a weathered stone in a quiet corner of a garden, or gently lift a decaying log in a woodland, and you are very likely to disturb a bustling community of pill bugs. These are their castles, their fortresses against the desiccating sun and the prying eyes of predators. The underside of such objects provides a stable microclimate, trapping moisture and offering a plethora of crevices and small spaces where they can retreat. Here they are shielded from the extremes of temperature, finding a cool refuge on a hot day and a slightly warmer haven when the air turns cold. Leaf litter, that rich, crumbly layer of fallen foliage that carpets the ground in forests and untended gardens, is another prime habitat. Within this organic blanket, pill bugs find not only shelter but also a significant portion of their diet. The decaying leaves, twigs, and other plant matter create a complex, three-dimensional world, a labyrinth of tunnels and chambers perfect for these small isopods. The very process of decomposition, driven by fungi and bacteria, helps to maintain the high humidity levels that pill bugs find so agreeable, creating a self-sustaining ecosystem for them. You may also find them congregating in compost heaps, those man-made mounds of organic recycling. Here, the conditions are often ideal, abundant, decaying vegetable matter providing an endless feast, and the natural heat generated by decomposition creating a warm, moist environment, especially in the cooler months. While some gardeners might view them with suspicion, their presence in a compost pile is generally beneficial, as they contribute to the breakdown of organic materials, accelerating the creation of nutrient-rich compost that will eventually nourish new plant life. The key to their habitat choice is always the presence of water, or at least high relative humidity. They are terrestrial, yes, but they carry the legacy of the sea within them. If their environment becomes too dry, they risk desiccation, their delicate respiratory structures ceasing to function effectively. This is why they are most active at night or on overcast, damp days when the risk of water loss is minimized. During prolonged dry spells, they will burrow deeper into the soil or seek out the most moisture-retentive hiding places, entering a state of reduced activity until conditions improve. Their distribution is vast. Pill bugs and their close relatives can be found on every continent except Antarctica. This global success is a testament to their adaptability, provided their fundamental need for moisture is met. From the damp undergrowth of temperate forests to the irrigated soils of suburban gardens, and even in the humid interiors of greenhouses, these creatures have carved out a successful niche. They are often unseen, going about their business beneath our notice, but they are a constant and vital presence in these specific microhabitats. Ultimately, the habitat of a pill bug is a world of shadows and dampness, a place of rich organic decay and constant subtle activity. It's a realm that requires us to get down on our hands and knees, to peer into the darkness, to appreciate the intricate web of life that thrives just out of sight. Understanding where they live is to understand what sustains them and to appreciate the delicate balance they require to flourish. These tiny, armored navigators of the terrestrial yet perpetually water-linked world. The diet of a pill bug, while perhaps not glamorous, is of immense ecological importance. These creatures are primarily detritivores, meaning they feed on dead and decaying organic matter. Their culinary world is one of fallen leaves, rotting wood, decomposing fruits, and the tender tissues of plants that have completed their life cycle. They are nature's miniature cleanup crew, tirelessly working to break down the debris that accumulates on the forest floor and in our gardens, playing a vital role in the great cycle of nutrient replenishment. Imagine a fallen leaf, once vibrant green, now turning brown and brittle. To us, it is merely a sign of autumn's passage, but to a pill bug, it is a potential feast. Using their small but effective mouth parts, they gnaw away at the softened tissues, consuming the cellulose and lignin that other creatures might find indigestible. They are not typically predators, nor are they usually interested in healthy, living plants, though occasionally, if other food sources are scarce or conditions are exceptionally crowded, they might nibble on very tender seedlings, leading to their occasional, though often overstated, reputation as garden pests. Fungi and microbes play a crucial preparatory role in the pill bug's diet. As organic matter begins to decay, it is first colonized by a host of bacteria and fungi. These microorganisms start the process of breaking down complex compounds, effectively pre-digesting the material. Pill bugs are then drawn to this microbe-rich food, benefiting not only from the decaying plant matter itself, but also from the nutritious fungi and bacteria growing upon it. It's a synergistic relationship where the pill bug consumes the seasoned detritus, further fragmenting it and exposing more surface area for microbial action. Their feeding activity is relentless, though often unseen. A colony of pill bugs can make a significant impact on the rate of decomposition in their local environment. By shredding and consuming organic litter, they accelerate the release of essential nutrients like nitrogen, phosphorus, and potassium back into the soil. These nutrients then become available for uptake by living plants, fueling new growth and maintaining the health of the ecosystem. Without these humble detritivores, the forest floor would accumulate debris much more rapidly, and the cycling of vital elements would be significantly slowed. Interestingly, pill bugs also practice coprophagy, the consumption of feces. This might seem unappetizing to us, but for pill bugs, it's a vital nutritional strategy. Their own droppings, and sometimes those of other pill bugs, still contain a significant amount of partially digested organic matter and, crucially, microorganisms that continue the breakdown process. By re-ingesting this material, they can extract further nutrients that were missed on the first pass. This efficient recycling system ensures they get the maximum benefit from the often nutrient-poor food sources they rely upon. Furthermore, pill bugs have a unique ability to tolerate heavy metals. They can sequester metals like copper, zinc, cadmium, and lead into specialized granules within their hepatopancreas, effectively removing these potentially toxic substances from the soil and preventing them from entering higher levels of the food chain. While this makes them resilient to polluted environments to some extent, it also means they can act as bioindicators of heavy metal contamination. Their dietary habits therefore have implications far beyond simple sustenance. They are actively detoxifying their surroundings. So the next time you see a pill bug diligently munching on a piece of decaying wood or a forgotten leaf, remember the crucial role it is playing. It is not merely feeding itself, it is participating in a grand natural process of renewal and purification. These tiny recyclers, fueled by the detritus of the plant kingdom, are essential for the health of our soils and the vitality of the ecosystems they inhabit, transforming death and decay into the building blocks of new life, a quiet, ceaseless, and profoundly important task. Chapter 4: The Art of Conglobation, a Pill Bug's Armor. In a world teeming with potential threats from voracious spiders and predatory beetles to curious birds and small mammals, the humble pillbug possesses a remarkably effective defense mechanism. It is a strategy elegant in its simplicity, yet highly successful. The ability to roll itself into a tight, almost impenetrable ball. This behavior, known as conglobation, is what gives the roly-poly its evocative name and transforms it from a soft-bellied crawler into a miniature armored sphere, a tiny fortress of solitude. When a pillbug perceives danger, perhaps the vibrations of an approaching footstep, the shadow of a predator, or a direct touch, its response is often instantaneous. Specialized sensory hairs and its simple eyes detect the threat, triggering a rapid sequence of muscle contractions. Segment by segment, its body begins to curl inwards, the head tucking down, the tail end curving up to meet it. The articulated plates of its exoskeleton, known as tergites, slide and interlock with remarkable precision, forming a near-perfect sphere. This spherical form offers several defensive advantages. Firstly, it presents the toughest, most heavily armored parts of its exoskeleton to the outside world, shielding its softer underbelly, delicate legs, and vulnerable head. Many smaller predators, equipped with mouthparts designed for grasping or piercing, find it difficult to get a purchase on this smooth, hard ball. The lack of any obvious weak points can frustrate an attacker, causing it to lose interest and move on in search of easier prey. It's a passive defense, but an incredibly effective one. Secondly, the rolled-up state can make the pillbug more difficult to consume. For a predator with a small gape, swallowing a hard, round object can be challenging, if not impossible. It might simply be too awkward to manipulate or ingest. Furthermore, by remaining perfectly still within its protective ball, the pillbug may cease to register as living prey to some predators whose hunting strategies are triggered by movement. It becomes, in essence, a tiny, unappetizing pebble easily overlooked in the complex tapestry of the forest floor. Not all terrestrial isopods can perform this feat of conglobation. The true pillbugs, belonging to the family Armadillidae, are the masters of this art, their body shape and segment articulation perfectly evolved for this defensive posture. Other related isopods, like sowbugs, family Porcellonidae, can only curl slightly and cannot form a complete ball, leaving their legs and antennae exposed. This ability is a key distinguishing feature and a significant factor in the pillbug's survival success in diverse environments. The decision to roll up is not taken lightly, as it renders the pillbug immobile and unable to forage or escape further. It's a commitment to weathering the threat. The duration for which a pillbug remains in its defensive ball can vary, depending on the nature and persistence of the perceived danger. It will remain tightly coiled until its sensory systems indicate that the coast is clear, at which point it will slowly, cautiously begin to unroll, testing the environment before fully extending its legs and resuming its normal activities. This careful re-emergence is crucial to avoid unrolling directly into renewed danger. This defensive rolling is an innate behavior, present even in very young pillbugs, though their smaller size and softer exoskeletons offer less protection than those of the adults. It is a testament to the power of natural selection, a simple yet brilliant adaptation that has allowed these creatures to thrive for millions of years. The next time you gently encourage a pillbug to display its remarkable talent, take a moment to appreciate the sophisticated biomechanics and evolutionary pressures that have shaped this perfect miniature sphere of defense, a tiny armadillo of the invertebrate world. Chapter 5. A Pocketful of Life Pillbug Parenthood. The reproductive strategies of the natural world are endlessly diverse, and the pillbug, despite its humble appearance, exhibits a form of parental care that is quite remarkable for such a small invertebrate. The story of pillbug reproduction is one of dedication and protection, ensuring the survival of the next generation in a world fraught with peril. It begins with the mating process, which, like many aspects of their lives, often occurs under the cover of darkness or in secluded, moist locations, away from the prying eyes of predators and the harshness of direct sunlight. Following successful mating, the female pillbug embarks on a period of profound physiological change. She develops a specialized structure on her underside, known as a marsupium or brood pouch. This is not a temporary construct, but an integral part of her reproductive anatomy, formed by overlapping plates called oostogytes that extend from the bases of some of her legs. This pouch serves as a self-contained nursery, a safe and humid environment where her eggs will develop, shielded from the external world's dangers and desiccating conditions. Into this protective marsupium, the female releases her fertilized eggs. The number of eggs can vary considerably, typically ranging from a few dozen to over 100, depending on the size and health of the female, as well as environmental factors. The eggs are small, pale, and delicate, and within the fluid-filled pouch, they are provided with the moisture essential for their development, a constant reminder of the pillbug's aquatic ancestry and its ongoing dependence on water for the most critical phases of life. The mother effectively carries her entire clutch with her as she forages and goes about her daily activities. The development of the embryos within the marsupium can take several weeks, the duration influenced by ambient temperature warmer conditions generally accelerating development. Throughout this period, the female is not merely a passive carrier. She actively maintains the conditions within the pouch, ensuring adequate humidity and perhaps even providing some degree of aeration through subtle movements. This maternal investment is considerable, as carrying a brood pouch full of developing young can make her slightly less agile and potentially more conspicuous to predators. Once the eggs hatch, tiny, underdeveloped young, known as mansae, emerge. As we've learned, these mansae are not yet fully formed. They lack the final pair of legs that characterize adult isopods. However, they do not immediately leave the safety of the marsupium. Instead, they remain within this protective haven for a further period, often a week or two, undergoing their first molt and continuing to draw nourishment, possibly from fluids secreted within the pouch or from yolk reserves. This extended stay provides a crucial buffer, allowing them to grow stronger before facing the challenges of independent life. The moment of emergence from the marsupium marks a significant transition. The young pillbugs, now slightly larger and more robust, crawl out from beneath their mother one by one or in small groups, ready to explore their surroundings and begin foraging for themselves. The mother provides no further direct care after they leave the pouch, her parental duties fulfilled. She will soon molt, shedding the oostogytes of the brood pouch, and prepare for the possibility of another reproductive cycle if conditions are favorable. This remarkable system of carrying developing eggs and young in a specialized pouch is a highly successful adaptation. It provides a level of protection for the offspring that far exceeds what would be possible if eggs were simply laid in the soil or under a leaf. It ensures a higher survival rate for the vulnerable early stages of life, contributing significantly to the pillbug's ability to maintain robust populations in its chosen habitats. It is a quiet testament to the power of parental investment, even in the world of miniature crustaceans, a pocketful of life carefully nurtured. Chapter 6: Gentle Giants of the Undergrowth, Dispelling the Myths. In the grand tapestry of garden invertebrates, the pillbug often finds itself subject to misconceptions. Its appearance, somewhat insect-like to the untrained eye, and its tendency to be found in numbers can sometimes lead to unwarranted concern. However, when we delve into the true nature of these creatures, we find that the question, "Are they dangerous?" can be answered with a resounding and reassuring no. Pillbugs are by and large entirely harmless to humans, pets, and indeed to most of the living things they encounter. Their primary defense, as we've explored, is to roll into a ball, a passive act of self-preservation rather than aggression. They possess no venom, no sting, and their mouth parts, designed for chewing soft, decaying plant matter, are far too small and weak to inflict any kind of bite on human skin. Holding a pillbug in your hand is a perfectly safe endeavor. You might feel the tickle of its many tiny legs as it explores, or witness its impressive rolling act if it feels alarmed. But there is no threat of injury. This gentleness makes them excellent subjects for children to observe and learn about nature up close. Similarly, our beloved household pets, such as cats and dogs, have little to fear from pillbugs. Most pets will likely ignore them entirely. A curious cat might bat at a moving pillbug, or a dog might sniff inquisitively, but the pillbug's defensive role usually puts an end to any prolonged interaction. They are not poisonous if accidentally ingested, though they are unlikely to be a tempting snack for most animals. Their presence in a home garden alongside pets is a sign of a healthy, functioning micro-ecosystem, not a cause for alarm. Concerns sometimes arise among gardeners about potential damage to plants. It is true that if populations are extremely high and their preferred food source, decaying organic matter, is scarce, pillbugs may occasionally nibble on the tender leaves of young seedlings or ripe soft fruits that are already touching the ground. However, significant damage to healthy, established plants is rare. They are far more likely to be found cleaning up fallen petals, overripe berries, or leaves that are already beginning to senesce, playing their role as decomposers rather than primary pests. In fact, their presence is often an indicator of moist conditions, which might be conducive to certain plant diseases, but the pillbugs themselves are not the cause of these diseases. They are merely taking advantage of the environment and the decaying matter that might result from such conditions. Proper garden hygiene, such as removing excessive rotting debris from around vulnerable plants and ensuring good air circulation, is usually enough to prevent any minor issues from escalating. And it keeps the pillbug population focused on their beneficial recycling duties. It's important to distinguish pillbugs from other more destructive garden inhabitants. Their slow movement and preference for damp, dark places mean they are often scapegoated for damage done by faster, more voracious pests like slugs, snails, or certain caterpillars which are active under similar conditions. A careful examination of the type of damage, and indeed a search for the actual culprits, often active at night, will usually exonerate the humble pillbug from any serious accusations of widespread garden vandalism. So, far from being dangerous, pillbugs are gentle, retiring creatures that contribute positively to their environment. They are a harmless and fascinating part of the biodiversity in our backyards and beyond. Their peaceful coexistence with humans and pets underscores their benign nature. Understanding this allows us to appreciate them not as a threat, but as tiny, armored allies in the maintenance of a healthy garden, quietly performing their essential ecological services without fanfare or fuss. True, gentle giants of the undergrowth. Chapter 7. The tiny titans of decomposition, a pillbug's purpose. In the intricate web of life, every creature, no matter how small or seemingly insignificant, has a role to play. For the pillbug, this role is fundamental to the health and vitality of terrestrial ecosystems. They are among the primary agents of decomposition, the unsung heroes who tirelessly work to break down dead organic matter, returning essential nutrients to the soil where they can be reused by plants. This process is critical for the continuation of life, a natural recycling program operating on a vast and constant scale. Consider the annual fall of leaves in a deciduous forest or the natural decay of plants in a meadow. Without decomposers like pillbugs, this organic material would accumulate, locking up vital nutrients and smothering new growth. Pillbugs, with their preference for detritus, step into this crucial niche. They shred fallen leaves, decaying wood and other plant remains, physically breaking them down into smaller particles. This fragmentation greatly increases the surface area available for even smaller decomposers such as bacteria and fungi to continue the work. This mechanical breakdown is just the beginning of their contribution. As pillbugs consume and digest organic matter, they transform it chemically. Their digestive processes release nutrients that were bound within the plant tissues, converting them into forms that are more readily available for uptake by living plants. Their droppings, or frass, are rich in these processed nutrients, acting as a natural fertilizer that enriches the soil. They are, in essence, miniature composting machines, constantly tilling and enriching the topsoil. Beyond nutrient cycling, pillbugs also contribute to soil structure and aeration. As they move through the leaf litter and the upper layers of soil, their burrowing activities create small channels and pores. These tiny tunnels help to improve water infiltration and air circulation within the soil, conditions that are beneficial for plant roots and other soil-dwelling organisms. A healthy population of pillbugs can thus contribute to a more friable, fertile and well-aerated soil environment, enhancing overall soil health. Their role extends to the fascinating realm of heavy metal remediation. As we've touched upon, pillbugs have the remarkable ability to accumulate certain heavy metals from the soil and decaying matter they consume, sequestering these potentially toxic elements within their bodies. By locking up metals like lead, cadmium and copper, they can help to reduce their bioavailability in the ecosystem, preventing them from being absorbed by plants or leaching into waterways. This makes them important, albeit tiny, players in environmental detoxification, especially in areas with historical pollution. The activity of pill bugs also influences the composition of microbial communities in the soil. By selectively grazing on certain types of fungi and bacteria, and by distributing microbial spores through their movements and frass, they can alter the balance of these microscopic decomposers. This, in turn, can affect the overall rate and pathways of decomposition, influencing the complex biogeochemical cycles that underpin ecosystem functioning. They are not just passive consumers, but active participants shaping their microbial landscape. Therefore, the environmental role of the pill bug is far more significant than their small size might suggest. They are tiny titans of decomposition, crucial engineers of soil health, and silent guardians against certain pollutants. Their ceaseless activity, largely hidden from our view, is essential for the productivity and resilience of the ecosystems they inhabit. Appreciating their purpose allows us to see them not as mere curiosities, but as vital cogs in the grand machinery of nature, performing a service that benefits us all. On Chapter 8. An astonishing adaptation, the pill bug's peculiar thirst. The world of invertebrates is replete with astonishing adaptations, ingenious solutions to the challenges of survival. The pill bug, a creature we might think we know well, harbors a secret that is both peculiar and remarkably clever, particularly concerning its most vital need, water. While they absorb some moisture from their food and through their general body surface in highly humid environments, they possess a truly unique method for drinking, one that defies our usual expectations of how an animal quenches its thirst. These terrestrial crustaceans, still tethered to their aquatic past, have evolved a specialized way to take in liquid water directly, not through their mouthparts as one might assume, but through their rear end. At the posterior tip of their abdomen, pill bugs possess a pair of specialized appendages called uropods. These structures, which in their aquatic ancestors may have served as swimming aids or parts of a tail fan, have been ingeniously repurposed in these land dwellers for a very different yet equally vital function. When a pill bug encounters a droplet of water or a surface film of moisture, it can position its rear end so that these uropods make contact with the liquid. The uropods are structured with fine capillary-like channels. Through capillary action, water is drawn up these channels, moving along the underside of the pill bug's body towards its anterior end. It's a remarkable feat of natural engineering, allowing them to drink efficiently without having to immerse their head or risk drowning their delicate gill-like respiratory organs. This method of water uptake is particularly advantageous for creatures living in environments where freestanding water might be scarce or available only in tiny amounts, such as dewdrops on leaves or condensation on the underside of rocks. They can exploit even the smallest sources of moisture, sipping water through these specialized posterior straws. It allows them to rehydrate quickly and efficiently, minimizing their exposure in potentially vulnerable situations while seeking out this essential resource. The efficiency of this system underscores the critical importance of water balance for pill bugs. Their exoskeleton, while offering protection, is not as impervious to water loss as the waxy cuticle of an insect. They are constantly at risk of desiccation, especially in drier conditions. This unique drinking mechanism, coupled with their behavioral adaptations like nocturnal activity and seeking humid shelters, is part of a suite of strategies that enable them to thrive on land despite their physiological limitations. Observing this behavior requires patience and a keen eye, perhaps a magnified view. To see a pill bug reverse towards a water droplet and subtly lower its rear, engaging its uropods, is to witness a small marvel of adaptation. It challenges our assumptions and highlights the diverse and often surprising ways in which life solves fundamental problems. It's a reminder that even the most common creatures can possess extraordinary abilities, hidden mechanisms that are key to their success. So this fun fact, this peculiar method of drinking through their rear end, is more than just an amusing tidbit. It is a profound illustration of evolutionary ingenuity. It demonstrates how existing structures can be modified over time to serve entirely new purposes, enabling a lineage to conquer new environments and persist through changing conditions. The pillbug's uropodal drinking is a testament to nature's endless creativity, a tiny detail that speaks volumes about the journey from water to land and the continuous adaptations required to sustain life in a challenging world. Thanks for joining us on this journey into the world of pillbugs. We've delved into their fascinating life cycle, from their humble beginnings in a maternal pouch to their armored adulthood. We've explored their preferred shadowy, moist habitats and uncovered the secrets of their diet, realizing their crucial role as nature's recyclers. These small creatures, with their remarkable ability to roll into a protective ball, are far more complex and important than many might imagine, true architects of soil health and miniature marvels of adaptation. We've learned that they are entirely harmless, gentle denizens of our gardens and wild spaces, and that their environmental contributions are immense, from nutrient cycling to even mitigating certain pollutants. And who could forget their peculiar yet ingenious method of drinking through their uropods? Each fact we've uncovered today paints a richer picture of these common yet extraordinary terrestrial crustaceans. Hopefully you now see the roly-poly bug not just as a tiny crawler, but as a vital participant in the intricate dance of life that unfolds all around us, often just beneath our notice. Don't forget to like, share and subscribe for more fascinating nature facts. By fostering a deeper understanding and appreciation for even the smallest inhabitants of our planet, like the resilient roly-poly, we can all become better stewards of the natural world. There is always more to discover, more to learn and more to marvel at, right in our own backyards. Until next time, keep exploring and keep wondering at the incredible biodiversity that surrounds us every day.